Alright guys, today we're going to be talking about sequence of transformations. This is 1.14. Our learning targets today are I can perform a sequence of transformations, and I can show congruence by giving the sequence of rigid transformations that maps a figure onto another. So let's go ahead and get started. So first off, we're going to start with a composition. So the definition of a composition, well, that's just a combination of two or more transformations. So if two or more transformations are occurring, we have a composition of transformations. It's also known as a sequence. So if you see a sequence of transformations, it's the same thing, the same exact thing as a composition of transformations. So as we can see in this diagram here, we have the figure G. We also have these two parallel lines occurring, and we know that they're parallel because they both have a single arrow on them. So if they both only have one arrow, that means that they're parallel. If they both had two arrows, that also means that they're parallel. So it's the same as congruency marks. If you have equal number of arrows, it means that those are parallel to each other. So if I were to go ahead and take figure G here, if I were to take this letter, and I were to reflect it across line Q, it would end up looking like this G down here, this blue G. So I'll call this G prime for now. Now say that I take this G prime and I reflect it once again across line R. So I'm reflecting across this line this time. And as we can see, it's equidistant. Each point is equidistant to the line of reflection, so they're all equal distances. So now I reflect G prime across line R, and that will leave me with G double prime down here. So this figure at the bottom. Now, if you look at our original pre-image as well as our final image, they look like they have the same orientation. They're facing the same way. So that's the main key here. A composition of reflections across two parallel lines. So again, I just did two reflections across parallel lines. That is the same exact thing as a translation. So if I were just to translate figure G down and to the right, that's the same exact thing as the reflection over line Q, then a reflection over line R. So again, this is just a useful little trick that you guys can do, but any two reflections over parallel lines will always be the same exact thing as a translation. Now, if I have two intersecting lines, such as line U and line V here, if I have these two intersecting lines, then it's a little bit different. So if I were to go ahead and reflect this letter R across line U, it leaves me with this backwards looking R here. Now, it's very important that we look at line U and line V. We see that their intersection is 35 degrees. So this angle that they form by intersecting is 35 degrees. So I'm going to go ahead and take this backwards R now, and I'm going to reflect again, only this time I'm going to reflect across this intersecting line, this blue line, line V, and that will give me my final image over here, this blue image of R. So, if it's parallel lines, two reflections over those parallel lines will be the same as a translation. If they're intersecting lines, a composition of reflections, so again two reflections in a row across intersection lines, is the same as a rotation. Now, as for the rotation degree, the degree of rotation that we're doing, well, I'm going to take that angle that's formed by the intersecting lines, and all you have to do is double it. So if I double that angle, if I double 35, that tells me that it's a rotation of 70 degrees. Now if this angle is 20, it'd be the same as a rotation of 40 degrees. If this angle was 12, it'd be the same as a 24 degree rotation. So again, you're just doubling the angle measure made by these two intersecting lines. So this is the same as a rotation of 70 degrees, and of course we're going clockwise in this case. Alright, so here is our main focus of today, these practice problems. So you're going to draw the image of the figure after the following transformation. So xy turns to 2x comma y, which then is transformed into 1/4 x comma negative 1/4 y. So go ahead and pause the video, try this one out. What I'd like you guys to do is draw the figure, draw the image, as well as the second image, and then also write the coordinates out. I need to know these coordinates because this is going to be a very big deal on your test because it's all going to be in coordinate form. So find these coordinates and then draw the picture over here. Alright, so when we draw this, it should end up looking like this for A prime, B prime, C prime. So again, we're just doing a horizontal stretch. We're just stretching it out in the x direction because that's what we're multiplying x by. And since the number is bigger than 1, it's going to be a stretch. If it was smaller than 1, it would be a shrinkage. So this is a stretch here by a factor of 2 because that's what we're multiplying by. Now, we're going to take these new points, a prime, b prime, and c prime. There should be a c prime down here. And we're going to plug it into 1/4 x negative 1/4 y. So this is a dilation occurring because we're multiplying by the same number on both of them. Now, not only that, we're also reflecting over the x-axis because this is a negative y now. So we're taking all of our y values and we're negating them all as well. So a double prime, b double prime, c double prime should be 0, negative 1 for a double prime, 1, negative 2 for b double prime, and 2, negative 2 for c double prime. What is the series of transformations that led to this? So go ahead and pause the video if you need to. Think about it for a second. So the first thing that we did was a horizontal stretch. So again, we stretched it horizontally by a scale factor of 2. That's why this red is more stretched out than the blue. And then after that, we did a dilation with a scale factor of 1/4 because we multiplied both of these by 1/4. Now as we can see, it got smaller because we multiplied by a number less than 1. Now, once we did that dilation, we also combined that with a reflection over the x-axis because, again, we see this negative here, which tells me that I must reflect over the x-axis. All right, let's go ahead and try out our next one. So, a student was asked to reflect an image across the y-axis and then vertically stretch the figure by a factor of 3. What transformation would indicate these two steps in one? So what I am curious about is xy becomes what, and I want to do both of these transformations that are inside the strategic question. I want to do it all in one parenthesis here. So go ahead and pause the video, try that one out if you'd like. Let me know what xy turns into. Alright, so looking at this, we are reflecting over the y-axis. So if we're reflecting over the y-axis, all of our x values are going to be negated. They're all going to change whether they were positive or negative. Whoops, there's the answer. So it's now negative x, because again, we're just negating all these. We're reflecting across the y-axis. And then we're doing a vertical stretch. Now, if horizontal is a line like the horizon, like I'm drawing with the laser pointer right now, then vertical is straight up and down. So this is a vertical line. So if I'm doing a vertical stretch, which values am I multiplying? I'll be multiplying my y values because y deals with going up and down. So I'm stretching vertically by a scale factor of 3. So I'm multiplying by 3. So therefore it should be comma 3y. So if I want to do both of these transformations in one rule, I just need to do xy turns to negative x comma 3y. Alright, let's go ahead and continue. So, go ahead and pause the video if you'd like and try this problem out. Square PQRS, this square right here, it's rotated 180 degrees about the origin and reflected over the line y equals 2. Now before you get started on this, make sure that you take note of how much each box is worth in terms of value. And then also keep in track that we're just doing to double prime. So give me the coordinates and give me the images. Go ahead and pause the video and try this one out if you'd like. Alright, so first off, rotating this figure 180 degrees about the origin. Well, the rule for that is xy changes to, let's see, we're rotating 180 degrees, that'd be negative x, negative y. So we're just negating both our x values and our y values. So now we have p prime being negative 2, negative 2, q prime being negative 2, negative 4, r prime being negative 4, negative 4, and s prime being negative 4, negative 2. Next, we want to go ahead and reflect over the line y equals 2. So I'll go ahead and draw that in purple here. It's this line right here. Now, this line is parallel. It's parallel to our x-axis. So therefore, we're just going to do the same exact rule as a reflection over the x-axis, except we need to add one piece to it. So therefore, negative x, negative y now becomes x, because that won't change here, comma, negative y, because I'm reflecting over the x-axis, so my y is negated, and then it's y equals 2. So I need to double this number here. So if it's positive 2, it would be negative y plus 4. So that is our rule to get to our double prime here. So we go ahead and we reflect over the line y equals 2, and our image shows up as such. So I now have p double prime, q double prime, r double prime, s double prime. Coordinates p double prime being negative 2, 6, q double prime is negative 2, 8, r double prime is negative 4, 8, and s double prime is negative 4, 6. So looking at this, if I plugged in my value for p, negative 2, negative 2, it then becomes negative 2, comma, 2 plus 4. Same as negative 2, comma 6, which is the exact same thing that we got on the next slide. So our rule did work, and again, I just doubled the number that was that our line is equal to. So it'd be negative y, because again, it's a reflection still, so I need to follow that reflection. And then it's not over the axis, so it's going to be double the number of what the line is equal to. So plus 4. All right, and again, I did that rule with each of these points in blue to give me each of the points in red. All right, next up, go ahead and try and do this triangle. We are doing 3 different rigid motions, or 3 different transformations rather. We're doing a translation by the vector 4, 4, a rotation of 90 degrees counterclockwise about the origin, and then reflecting over the y-axis. So go ahead and pause the video, try this one out on your own, and then we'll go through it. All right, so our first rule, we have xy turning to x plus 4, comma, y plus 4. Again, we're adding 4 to both x and y based upon this vector here. So doing that, I'm going to take each of these points, and again, important that we note that each box is worth 2 in value. So if I go halfway, it's worth 1. So I'm going to take each of these boxes, and I'm going to add 4, so I'm going to add 2 boxes, and I'm going to go up 2 boxes. So our new image for A prime, B prime, C prime is as shown here. Next, I'm going to go ahead and rotate 90 degrees counterclockwise. So our rule for rotating 90 degrees counterclockwise is xy becomes negative yx. So I take each of these points, I plug it into our new rule, and that will give me A double prime, B double prime, C double prime is this green figure over here. Lastly, we're going to go ahead and take our final transformation, a reflection over the y-axis. And so for that, we have xy turns to negative x comma y. So I'm negating my x value. It becomes negative. So therefore, we end up with the final points of A double prime, B double prime, or sorry, triple prime, and C triple prime being 6, 3, 8, 1, and 9, 2. So those are our new points for our final image. Now when you're doing the test, I'm going to be either looking for the final image or I'm going to be looking for the points of the final image. So I don't need to see all this extra stuff in between. If you want to put it all in one rule as x, y, changes to whatever it may be, you can definitely do that as well. Other than that, just keep in mind I am looking for the coordinates, so writing the rule may make it a little bit faster for you guys. Alright, so we've now covered our learning targets for today. I can perform a sequence of transformations, and I can show congruence by giving the sequence of rigid transformations that maps a figure onto another. Make sure that you guys are studying those transformation rules. They will help you guys out a lot, especially the rotations and reflection rules. The homework for this topic, that will be due next Sunday at 11:59 p.m. That's September 13th, 2020. Other than that, have a great rest of your day, guys. Thank you for watching, and I'll see you in the next video.